The predictive model lacks precision, Maya. Our investors expect more accurate forecasting, my business partner said, dismissing my analysis in front of venture capitalists from Andreessen Horowitz. The investors frowned, concerned. My partner, Daniel Wright, smiled confidently and opened his laptop. Let me show you the machine learning algorithm I've developed for customer churn prediction. I sat in the Palo Alto conference room, watching Daniel present data science work that was unmistakably mine. The statistical models were mine. The feature engineering was mine. Even the specific algorithmic approaches and validation methodologies came directly from months of research and development I'd shared with him during our company partnership meetings. This was the 18th time in 20 months that Daniel had stolen my data science work and presented it as his own technical innovation to investors, clients, or industry conferences. I'd documented every instance meticulously, gathered irrefutable proof, and planned my response with the precision I brought to algorithmic validation. Because what neither Daniel nor these venture capitalists knew was that I'd already registered copyrights on all my original code and technical documentation, secured contracts with 3 major companies who wanted to work directly with me, and been approached by leading tech companies about senior data science positions. I'd also consulted with attorneys who confirmed that Daniel had no legal rights to models and code I'd created independently. In 72 hours, I would dissolve our company partnership and reveal that every innovative algorithm Daniel had been claiming credit for was actually my technical work, protected by copyrights and comprehensive code documentation. His company would lose its technical foundation, its major clients, and its industry credibility. Mine would launch with the models he'd tried to steal, proper attribution, and opportunities he'd blocked through his exploitation. Before we witness how a brilliant data scientist whose work was stolen for years used intellectual property law and industry connections to destroy her partner while launching her own successful consultancy, I want to thank you for being part of this community. A community that believes technical theft deserves the same consequences as any other stealing, and that code plagiarism should be exposed publicly. If you've had your data science work stolen, if you've watched partners take credit for your models, if you've been the invisible technical force behind someone else's company's success, this story will resonate deeply. Hit that subscribe button to join thousands who appreciate stories where documentation and strategic planning overcome exploitation in technical industries. Now let's step into the world of data science, where a talented analyst's work was systematically stolen by her charismatic business partner, where industry relationships enabled exploitation, and where 20 months of careful preparation created the foundation for complete professional destruction and technical triumph. My name is Maya Patel, and I'm a 32-year-old data scientist originally from Berkeley, California. I grew up in a family where my mother was a statistics professor at UC Berkeley and my father worked as a software engineer at Oracle. I was surrounded by discussions about probability theory, algorithms, computational complexity, and the intersection of mathematics and computation. Data science felt like my natural language from childhood, the perfect synthesis of my parents' complementary expertise. I learned about statistical analysis when I was 13 years old, helping my mother grade undergraduate statistics assignments and prepare lecture materials. She taught me about hypothesis testing, about how data needed to be analyzed rigorously to draw valid conclusions, about the responsibility statisticians had to avoid misleading interpretations and respect uncertainty. Those lessons shaped everything about how I approach data science, emphasizing intellectual honesty alongside technical skill. My mother's academic work focused on Bayesian statistics and experimental design. She'd explain probability distributions, conditional probability, how to update beliefs based on evidence. I learned that statistical thinking required balancing mathematical rigor with practical interpretation. She taught me that good data analysis combined technical precision with clear communication about uncertainty and limitations. I remember one specific project when I was 15, helping my mother analyze data from a psychology experiment about decision-making under uncertainty. We explored the dataset together using our statistical software, tested different statistical models to see which best fit the observed patterns, discussed what the results meant substantively and what they didn't mean, what conclusions were justified versus speculative. Seeing how careful analysis could reveal meaningful patterns while avoiding overinterpretation was profoundly influential. My mother emphasized that good statistics meant being honest about uncertainty, acknowledging limitations, and resisting pressure to overclaim from data. My father contributed the computational perspective to my data science education. As a software engineer working on database systems, he taught me about algorithms, data structures, and computational efficiency. He'd explain how to write clean code, how to optimize performance, how software needed to be both correct and maintainable. I learned that data science required strong programming skills alongside statistical knowledge. During high school, I participated in data science competitions and statistical modeling challenges. I competed in Kaggle competitions, developing machine learning models for various prediction tasks. I won several high school-level competitions, demonstrating early aptitude for combining statistical thinking with algorithmic implementation. The work felt like solving puzzles where the solution required both mathematical insight and coding skill. I earned a full scholarship to Stanford, studying statistics with a focus on machine learning and computational methods. Stanford was intellectually thrilling, learning from professors who were pushing boundaries of what data science could accomplish in technology and business applications. I was particularly interested in how predictive modeling could inform business decisions while accounting for uncertainty. My sophomore year professor, Dr. Jennifer Chen, had worked as a data scientist at Google and brought that industry experience to her teaching. She pushed us to think about practical constraints alongside theoretical optimization, to understand business contexts where models would be deployed, to build solutions that solved real problems rather than just achieving impressive benchmark performance on academic datasets. Her mentorship profoundly influenced my approach to applied data science. Dr. Chen's course on applied machine learning was transformative. Unlike traditional statistics courses that focused primarily on mathematical theory, she taught us to think about the entire data science pipeline from business problem definition through model deployment and monitoring. She'd assign projects based on real company challenges, forcing us to grapple with messy data, unclear requirements, and practical constraints that academic datasets never captured. One assignment involved building a recommendation system for a simulated e-commerce platform. The challenge wasn't just developing an algorithm that made accurate predictions but designing a complete system that could handle millions of users, update in real time, explain recommendations to users in understandable ways, and avoid creating filter bubbles that limited product discovery. The assignment taught me that production data science required balancing multiple competing objectives. Dr. Chen also emphasized the importance of understanding when sophisticated machine learning wasn't necessary. She'd show us examples of companies that had built complex deep learning systems when simple heuristics or basic statistical models would have worked better. She taught us to start with simple baselines, understand their performance characteristics, and only add complexity when simpler approaches proved insufficient. During junior year, I interned at LinkedIn's data science team working on recommendation algorithms. The experience taught me about data science at industrial scale, about the engineering challenges of deploying models in production systems serving hundreds of millions of users, about balancing model sophistication with computational efficiency and interpretability requirements. My internship project focused on improving LinkedIn's People You May Know feature, which recommended connection suggestions to users. The existing system used collaborative filtering based on network structure and profile similarity. While effective, it had known limitations including cold start problems for new users and tendency to recommend only people very similar to existing connections. I was tasked with exploring whether incorporating content signals from user activity could improve recommendation quality. This meant analyzing what articles people read, what posts they engaged with, what jobs they viewed, and using those behavioral signals alongside network structure to identify potentially valuable connections that weren't obvious from profile similarity alone. The technical challenge was significant because LinkedIn's scale meant any algorithm needed to run efficiently on massive datasets. I couldn't use approaches that required computing similarity between all possible user pairs. I needed methods that could handle hundreds of millions of users while updating recommendations frequently as new data arrived. I developed a hybrid approach that combined network-based collaborative filtering with content-based signals using approximate nearest neighbor techniques for efficiency. The system used locality-sensitive hashing to identify candidate connections from content similarity, then ranked candidates using gradient boosting that incorporated both network and content features. The approach achieved meaningful improvements in recommendation quality while maintaining computational feasibility. The improved recommendation system increased connection acceptance rates by 18% during A/B testing. Users were discovering valuable connections they wouldn't have found through the previous algorithm. The project demonstrated that thoughtful feature engineering and algorithm selection could create measurable business value even with computational constraints. The internship also taught me about the organizational aspects of data science in large companies. I learned about experiment design, A/B testing methodology, how to communicate results to product managers and engineers, how to navigate stakeholder concerns about changing established systems. The experience prepared me for corporate data science practice in ways that academic coursework couldn't. One project involved developing a machine learning model to predict which connection suggestions users would actually accept versus ignore. The challenge was significant because naive models had poor precision, suggesting many connections users weren't interested in, which degraded user experience and wasted computational resources. I needed to develop an approach that better understood connection relevance while avoiding filter bubbles that limited network diversity. I experimented with various feature engineering approaches, incorporating network structure features like mutual connections and network distance, content similarity signals from profiles and activity, and behavioral patterns like users' historical acceptance rates and interaction patterns. I tested different algorithms including gradient boosting, neural networks, and ensemble methods, evaluating performance across different user segments to ensure the model worked well for diverse populations. The final model I developed improved precision by 28% while maintaining recall, meaningfully enhancing user experience by showing fewer irrelevant suggestions. The improvement was particularly strong for users with smaller networks who benefited most from high-quality recommendations. The project resulted in my first technical publication as co-author on a paper LinkedIn presented at a Rexus conference. My senior thesis involved developing interpretable machine learning models for medical diagnosis support. The challenge was creating models that were both accurate and explainable to clinicians who needed to understand predictions to make treatment decisions. Black box models might achieve high accuracy but weren't useful if doctors couldn't understand or trust them. I developed an approach combining gradient boosting for prediction with SHAP values for interpretation, creating a system that provided both accurate diagnoses and clear explanations of which features drove each prediction. The thesis earned departmental honors and was featured in machine learning publications as an example of balancing accuracy with interpretability in high-stakes applications. After graduation, I joined Airbnb's data science team, working my way from junior data scientist to senior data scientist over 5 years. The experience taught me about the business of data-driven product development, about communicating with stakeholders, about coordinating across engineering, product, and business teams to deploy models that created measurable value. My first major independent project at Airbnb was developing a dynamic pricing model to help hosts optimize their listing prices. The existing pricing suggestions were relatively simple, based mainly on similar listings and seasonal patterns. I wanted to develop a more sophisticated approach that considered dozens of factors and adapted to real-time market conditions. I built a machine learning system that analyzed hundreds of features including listing characteristics, host behavior, local events, seasonal patterns, competitive dynamics, and demand signals. The model used gradient boosting to predict optimal prices that would maximize booking probability while maintaining good revenue for hosts. The system needed to balance multiple objectives and account for heterogeneous host preferences. The dynamic pricing model I developed increased booking rates by 12% while maintaining host revenue, a significant improvement that directly impacted Airbnb's marketplace efficiency. The project demonstrated my ability to develop sophisticated technical solutions that created measurable business value. Airbnb filed a patent on the pricing algorithm with me as primary inventor. I worked on numerous high-impact projects during those 5 years at Airbnb, developing data science solutions that became critical components of the platform's marketplace efficiency and user experience. Each project taught me something valuable about applying machine learning to real business problems while navigating organizational complexities and technical constraints. A fraud detection system that identified suspicious listings and prevented scams while minimizing false positives that could harm legitimate hosts. The challenge with fraud detection was balancing sensitivity against specificity in highly imbalanced datasets where fraudulent listings were rare but costly. I developed an ensemble approach combining multiple specialized models, each designed to detect different fraud patterns. The fraud detection system used anomaly detection for identifying unusual listing characteristics, supervised learning for predicting fraud probability based on historical patterns, network analysis for detecting coordinated fraud rings, and natural language processing for identifying suspicious listing descriptions and communications. The ensemble combined predictions from these specialized models using a meta-learner that calibrated the overall fraud score. The system achieved 94% precision at 20% recall, meaning we could identify 1 in 5 fraudulent listings with very high confidence while avoiding falsely flagging legitimate hosts. The business impact was substantial, preventing an estimated $12 million in fraud-related losses during the first year of deployment while maintaining host satisfaction with the platform. A search ranking algorithm that improved relevance and conversion by better understanding user intent and preferences. Search was critical to Airbnb's business because most bookings started with users searching for accommodations in specific locations. The challenge was personalizing search results based on user preferences while maintaining diversity and avoiding creating filter bubbles that limited discovery. I developed a learning-to-rank model that incorporated hundreds of features describing listings, users, and the search context. The features included obvious signals like price, location, and availability as well as subtle indicators like listing photo quality, host responsiveness patterns, review sentiment, and seasonal popularity trends. The model used gradient boosting with carefully tuned regularization to avoid overfitting. The improved search ranking increased booking conversion rates by 9%, a substantial improvement that translated directly to platform revenue. The model was particularly effective at understanding implicit user preferences, learning from their browsing and booking behavior to personalize results even for users who hadn't explicitly specified detailed preferences. A host quality scoring model that helped maintain platform standards by identifying hosts who consistently provided excellent experiences versus those creating problems. Quality standards were essential to Airbnb's reputation and user trust. The challenge was developing objective, fair metrics that captured host quality across diverse property types and markets while avoiding biases that could disadvantage certain host populations. I built a multi-level model that evaluated host quality across multiple dimensions including guest satisfaction scores, response time and communication quality, listing accuracy, cleanliness standards, and reliability metrics like cancellation rates. The model used hierarchical Bayesian approaches to share information across similar listings while accounting for varying sample sizes and market-specific expectations. The quality scoring system enabled targeted interventions to help struggling hosts improve while providing recognition and benefits to consistently excellent hosts. The model identified specific areas where hosts were underperforming, enabling personalized feedback and support. Platform-wide metrics showed measurable improvements in guest satisfaction in the months following deployment. A demand forecasting system that informed capacity planning, marketing investments, and strategic decisions about market expansion. Accurate demand forecasting was crucial for business planning because Airbnb's operations, marketing, and product teams all needed reliable predictions about future booking volumes across different markets and time horizons. I developed a hierarchical time series forecasting system that modeled demand at multiple geographic granularities from individual neighborhoods to entire countries. The approach used state space models combined with external regressors capturing seasonal patterns, local events, economic conditions, and competitive dynamics. The system generated probabilistic forecasts with calibrated uncertainty estimates. The forecasting system achieved mean absolute percentage errors below 8% for monthly forecasts and below 15% for weekly forecasts, substantially better than the previous heuristic approaches. The improved accuracy enabled more efficient capacity planning and marketing budget allocation, reportedly saving millions in wasted marketing spend in oversaturated markets. One project I'm particularly proud of involved developing a machine learning model to predict which guest-host interactions would result in problems or negative reviews, enabling proactive intervention before issues escalated. This was technically challenging because negative outcomes were rare in highly imbalanced datasets, and the signals predicting problems were often subtle and emerged from complex interaction patterns. Early warning signals came from multiple sources including messaging patterns between guests and hosts, booking characteristics like advance notice and length of stay, user histories including previous reviews and cancellations, and temporal features like day of week and season. The challenge was identifying which combinations of these signals indicated elevated risk of problems. I developed an ensemble model combining multiple specialized classifiers. A neural network analyzed messaging text and communication patterns to detect signs of confusion or conflict. A gradient boosting model incorporated structured features about bookings and user histories. An anomaly detection component identified unusual patterns that didn't fit typical successful booking profiles. The ensemble combined these specialized models' predictions using calibrated probability estimates. The model achieved impressive precision identifying high-risk bookings, with 80% of flagged bookings resulting in either intervention preventing a problem or confirmation of an issue that did occur. The system enabled Airbnb's customer service team to proactively reach out to guests and hosts when the model identified elevated risk, often preventing negative experiences through simple clarifications or assistance. The intervention program reduced negative review rates by 15%, a significant improvement in user satisfaction that enhanced platform reputation and repeat usage. The project demonstrated the value of predictive modeling for proactive customer service rather than just reactive problem solving. It became a model for how machine learning could improve operational efficiency while enhancing user experience. By my 4th year at Airbnb, I'd become known internally as someone who could develop innovative solutions for complex prediction problems where conventional approaches had proven insufficient. Senior leadership would assign me the most challenging projects, the ones requiring both technical sophistication and business judgment to navigate ambiguous requirements and competing constraints. I received consistently strong performance reviews emphasizing my technical capabilities, business impact, and collaborative approach. I was promoted to senior data scientist, given larger projects with more autonomy, and increasingly consulted on strategic decisions about product development and marketplace dynamics. I mentored junior data scientists and contributed to improving the team's technical standards and best practices. But I was growing frustrated by the limitations of working within a single company's ecosystem and priorities. I wanted to work on diverse problems across different industries rather than solely on Airbnb's marketplace challenges. I wanted more direct interaction with business stakeholders and strategic decisions rather than working through organizational hierarchies. I wanted the independence to pursue my own technical vision. I wanted to pursue my own vision for applied data science consulting, to work across multiple industries and problem domains rather than focusing solely on one company's products. I wanted my own consultancy where I could fully express my technical capabilities without filtering through corporate priorities and organizational hierarchies. At 29, I decided to start my own data science consulting firm. I had strong technical skills, proven track record of impactful models, and enough industry connections to make independence feasible. What I didn't have was business development capabilities, established client relationships, or the operational infrastructure that consulting firms needed to secure major contracts. I met Daniel Wright at a machine learning conference in Las Vegas. He was 41, charismatic and well-connected, with an MBA from Wharton and 15 years of experience in technology consulting and business development. He approached me after my presentation about interpretable machine learning, saying he'd been looking for a talented data scientist partner to build a firm focused on advanced analytics solutions. We met for coffee the following week at a cafe in Menlo Park. Daniel talked enthusiastically about his vision for a boutique data science consultancy that could compete for premium corporate contracts while maintaining technical excellence. He said the market had strong demand for sophisticated machine learning solutions, but that most firms either lacked technical depth or couldn't effectively engage with enterprise clients. Daniel explained his background in technology consulting had taught him how Fortune 500 companies approached analytics investments. He understood procurement processes, legal requirements, financial structures that made consulting firms attractive to enterprise clients. He knew how to position technical services to appeal to CTOs willing to pay premium rates for exceptional data science work. He said this business acumen combined with my technical capabilities would create something unique. Over several meetings, Daniel outlined how a partnership might work. He'd handle all business development, client acquisition, contract negotiation, and firm operations. I'd focus entirely on data science, working with clients on technical solutions and managing all model development and deployment. The division seemed perfect, allowing me to concentrate on technical work while someone else handled aspects of consulting I found less engaging. Daniel had connections to technology executives at major companies, understood the business side of technical consulting, and could handle everything from client acquisition to financial management. He said my data science talent combined with his business expertise would create a formidable partnership. The division of responsibilities seemed ideal. We formed Wright Patel Analytics as a 50-50 partnership, both our names on the LLC documents. Daniel handled initial business development while I focused on building our technical capabilities and service offerings. We secured office space in Palo Alto with the infrastructure that would impress potential enterprise clients. The setup felt professional and promising. The office featured a combination of technical workspace and client presentation areas. Daniel insisted on premium equipment including GPU servers for model training, high-end workstations, and sophisticated visualization capabilities that would demonstrate our technical capabilities. We installed large monitors for presenting analytical results, whiteboards for technical discussions, and a small data center for production model deployment. Daniel hired a project manager and business operations coordinator, bringing professional structure to the firm's day-to-day functions. He designed branding and marketing materials with technical aesthetic. He set up business infrastructure, established banking relationships, negotiated vendor contracts, created project management systems. The operational foundation appeared solid and professional. The early months were productive. I developed data science case studies for different industry applications we wanted to pursue, creating a portfolio that showcased our firm's capabilities in predictive modeling, machine learning, and advanced analytics. Daniel would review work and provide feedback, always enthusiastic about the models I was producing. He'd bring potential clients to the office to see my technical work, presenting it as examples of what we could deliver. I created comprehensive technical proposals for various business problems that demonstrated our capabilities across different domains and methodologies. A customer churn prediction model for subscription businesses. A fraud detection system for financial services. A demand forecasting solution for retail inventory optimization. A recommendation engine for e-commerce personalization. A predictive maintenance model for manufacturing operations. Each proposal represented weeks of technical work. The churn prediction proposal included detailed feature engineering approaches, model selection rationale comparing multiple algorithms, validation methodology ensuring robust performance, deployment architecture for production systems, and business impact projections. I created technical documentation explaining every modeling decision. I shared everything with Daniel during this development phase, walking him through my analytical approach, explaining the statistical reasoning and algorithmic choices behind each model. I thought we were partners building a firm together, that my openness about technical decisions was normal collaboration between data science and business leadership. Daniel would ask technical questions during these reviews, showing genuine interest in understanding the data science work. He'd inquire about why I'd chosen specific algorithms, how I'd approached feature engineering for different problem types, what informed my decisions about model complexity and interpretability trade-offs. I appreciated his engagement, interpreting it as a business partner learning enough about data science to effectively represent our firm. The theft started subtly during client presentations. Daniel would describe models using language that subtly claimed technical credit. He'd say, "We developed," or "our algorithm," when discussing work I'd created entirely on my own. He'd present analytical results without clearly stating that I'd performed all the technical development. At first, I told myself this was normal business communication, that Daniel was using inclusive language to present us as a unified firm. But the pattern became troubling when he started taking technical meetings without inviting me, returning with signed contracts for projects where clients thought Daniel was the lead data scientist. The first undeniable instance involved a complete customer analytics platform for a major telecommunications company. The client was a Fortune 100 company dealing with high customer churn rates in their mobile service business. They needed comprehensive predictive models to identify at-risk customers, understand churn drivers, and inform retention strategies. I spent 5 months developing the complete analytics solution. I analyzed millions of customer records, exploring patterns in usage behavior, billing history, service interactions, and competitive dynamics. I engineered hundreds of features capturing different aspects of customer behavior and satisfaction. I tested multiple modeling approaches before developing an ensemble system that achieved exceptional prediction accuracy. The churn prediction model I developed used gradient boosting with carefully tuned hyperparameters, achieving 92% precision in identifying customers likely to churn within 30 days. The model incorporated interpretability features using SHAP values so business teams could understand why specific customers were flagged as at risk. The system included automated retraining pipelines and monitoring to maintain performance over time. I created comprehensive technical documentation describing every aspect of the modeling process. Feature engineering logic with business rationale. Algorithm selection and tuning methodology. Validation approach ensuring robust performance across customer segments. Deployment architecture for production integration. Business impact analysis projecting retention improvements and revenue protection. The complete analytics platform represented months of intensive technical work and innovation. I documented every modeling decision, created extensive code with clear comments, developed deployment specifications that would enable smooth production integration. Daniel attended the final presentation with me, positioned as firm principal while I was introduced as lead data scientist. During the presentation, I walked through the technical approach, explaining the modeling methodology and business applications. The client asked sophisticated questions about the algorithms and validation, and I provided detailed answers demonstrating deep understanding of their business and technical requirements. After the presentation, the client told us they were impressed with the solution and wanted to proceed with full deployment. They mentioned being particularly excited about Daniel's innovative approach to churn prediction, and his understanding of telecom customer analytics. I realized Daniel had positioned himself as the technical mind behind the models during pre-meeting conversations I hadn't been part of. 2 weeks later, Daniel showed me the signed contract. The client had committed to a major deployment with substantial ongoing support fees. Daniel seemed pleased with the deal, saying the telecom project would be perfect for establishing our firm's reputation for enterprise machine learning. But as he described the contract negotiation, I understood he'd claimed my technical work as his data science expertise. The theft escalated from there. Daniel began scheduling client meetings without including me, presenting my models as his own technical innovations. He'd return with signed contracts and tell me about projects he'd won using algorithms I'd developed. He was performing data science expertise he didn't actually possess, using my work to create an illusion of technical leadership. I started noticing patterns in how Daniel described our firm to prospective clients and in industry contexts. He'd talk about his approach to machine learning and his innovations in predictive modeling when discussing work I'd created entirely independently. He was building his professional reputation on my intellectual property while keeping me invisible. During one particularly frustrating presentation, Daniel used technical slides I'd created alongside a talk describing his modeling philosophy and his framework for robust prediction systems. Every algorithm showed work I'd developed, every technical insight came from my research, every methodological decision reflected my statistical thinking. But Daniel spoke about it all as if these approaches originated with him. I confronted Daniel after that presentation about claiming my data science work as his technical expertise. He looked at me with apparent confusion, as if my frustration was incomprehensible. He said that as partners in a consulting firm, all work was ours, regardless of who physically created it. He said I was being territorial about work that belonged to the partnership we'd built together. The conversation became an argument about ownership, attribution, and what partnership meant in technical professional contexts. Daniel insisted his business development and client relationships were equally valuable to my data science work, that the firm's success was collaborative even if I'd physically created all the models. He said demanding individual credit undermined our partnership and made me seem difficult to work with. I left that conversation feeling manipulated and diminished. Daniel had taken a legitimate complaint about intellectual property theft and reframed it as my personal problem with sharing recognition. He'd made me question whether I was being unreasonable to expect acknowledgement for creating every model our firm had produced. That evening, I called a former Stanford professor who'd become a mentor, Dr. Jennifer Chen. I described what was happening with Daniel. She listened carefully, then told me something that changed my entire understanding of the situation. She said she'd seen this pattern before in data science consulting, business partners systematically claiming credit from talented technical people, keeping them invisible while building reputations on stolen work. Dr. Chen emphasized that code and technical documentation were protected under copyright law. She explained that I automatically owned copyright on code I'd written, that I could register those copyrights for additional protection, and that comprehensive technical documentation would be crucial if I needed to prove authorship. Most importantly, she said I should immediately start protecting my work legally and documenting that all models were mine. She recommended consulting with attorneys specializing in intellectual property and software, registering copyrights on all my code and technical materials, keeping detailed development journals with Git commit histories, and building relationships with clients independent of Wright Patel Analytics. Following Dr. Chen's advice, I began systematically documenting my work and protecting my copyrights. I registered copyrights on every major piece of code I'd written for Wright Patel Analytics, submitting my original implementations, technical documentation, and development history. The copyright registrations established legal proof that I'd created the work, providing protection against Daniel's theft. I also started keeping detailed technical journals describing my development process for every project. I maintained rigorous Git version control with clear commit messages and timestamps. I saved all code with metadata showing creation dates and authorship. I archived model training logs and experimental results. I was building comprehensive evidence that would prove I'd created everything Daniel was claiming as his data science. The documentation process required maintaining parallel records of everything. I'd develop models on company servers, then push code to personal Git repositories with full history preserved. I'd email myself technical documentation and analysis reports. I'd save model artifacts and training data to personal storage. I was building an archive proving my authorship. Simultaneously, I began building professional relationships independent of Daniel and Wright Patel Analytics. I attended machine learning conferences alone, joined professional data science organizations, made sure people in the analytics community knew me as an actual practitioner rather than just Daniel's business partner. I was establishing my own professional identity. One particularly valuable connection came through a Women in Data Science network I joined. Through this group, I met several successful women data scientists who'd faced similar credit theft earlier in their careers. They shared strategies for protecting work, advice about leaving exploitative partnerships, and encouragement that my concerns about Daniel's behavior were legitimate and serious. One data scientist, Dr. Lisa Rodriguez, told me she'd left a consulting partnership 6 years earlier after her partner had systematically claimed credit for her technical work. She'd struggled initially after leaving but had built a successful independent practice. She emphasized the importance of having copyrights registered and comprehensive code documentation before confronting exploitation or dissolving partnerships. Lisa's story gave me both validation and strategic direction. I wasn't overreacting to Daniel's behavior. I was recognizing a serious pattern of professional theft that required careful response. The documentation I was gathering wasn't paranoid but necessary protection of my intellectual property and technical work. During this documentation period, I also started having careful conversations with clients we'd worked with through Wright Patel Analytics. I wanted to understand whether they knew I'd created the models Daniel had been presenting as his work. The conversations were revealing and disturbing. Multiple clients told me they'd assumed Daniel was the lead data scientist because of how he'd presented himself in initial meetings and ongoing communications. They'd believed they were hiring Wright Patel Analytics primarily for Daniel's technical expertise. Several expressed surprise when I explained I'd actually developed their models, saying Daniel had certainly implied the work was his technical output. One client, the CTO of a financial services company we'd built fraud detection for, was particularly direct. She told me she'd contracted with Wright Patel Analytics specifically because she was impressed with Daniel's presentation about machine learning and predictive modeling. She'd assumed the algorithms Daniel showed were his own technical work. When I showed her my code repositories and development documentation proving I'd created everything, she was shocked and concerned. The CTO said she felt misled, that she'd signed contracts believing she was getting Daniel's technical expertise when in reality Daniel had no data science capabilities. She told me explicitly that if I left Wright Patel Analytics and started my own consultancy, she'd want to work with me directly on future projects. She said several other technology executives she knew would likely feel the same way. These conversations confirmed that Daniel's credit theft wasn't just affecting my relationship with him but was damaging my professional reputation in ways that would impact my career long-term. Industry professionals thought he was the technical talent behind our firm when in reality he couldn't build a predictive model if his career depended on it. I also discovered that Daniel had been submitting papers to machine learning conferences with himself listed as first author and me as contributing researcher. 2 technical papers describing algorithms I'd developed had been submitted to major conferences with Daniel's name prominently featured. The papers used my code, my experiments, my technical writing, but listed Daniel Wright as primary contributor. After 20 months of careful preparation, I had everything I needed to leave the partnership and expose Daniel's theft. I had copyright registrations on all my code. I had comprehensive development documentation with Git histories. I had commitments from multiple companies to work with me independently. I had legal advice confirming my rights. I had job offers providing backup options. Most importantly, I had absolute certainty that leaving was the right decision. I scheduled a meeting with Daniel at our office on a Monday afternoon. I'd prepared everything carefully, consulting with my attorney about exactly how to handle the dissolution conversation. I had formal written notice of partnership dissolution. I had documentation proving my copyright ownership of all technical work. I had copies of evidence showing his systematic credit theft. Daniel seemed relaxed when I arrived at the conference room, probably assuming this was a routine project review. He had his laptop open, showing a technical presentation he'd prepared for a potential client pitch later that week. The presentation, predictably, featured my models presented as his innovations. I sat down across from him and placed a folder on the table. The folder contained copies of copyright registrations for every major project Wright Patel Analytics had completed, all registered in my name with comprehensive code and documentation. It contained Git histories proving my authorship. It contained evidence of 18 instances where Daniel had claimed my work as his own. It contained letters from clients confirming they'd work with me independently. I began speaking before Daniel could start his typical meeting routine. I told him I was dissolving our partnership effective immediately. The words came out calmly and clearly. Daniel's expression shifted from casual friendliness to confusion as he began processing what I'd said. "What are you talking about, Maya?" Daniel asked, closing his laptop. "Dissolve the partnership? If something's bothering you, we can discuss it. We've built something valuable here together." I explained that I owned copyright to every piece of code and every model Wright Patel Analytics had produced because I'd created them independently and registered them properly. I told him I'd documented his systematic misrepresentation of technical authorship and had legal counsel confirming his behavior constituted fraud. I pushed the folder across the table toward him. Daniel opened the folder and began reviewing the contents. I watched his expression shift as he saw page after page of copyright registrations, all in my name. He saw the Git commit histories. He saw documentation of instances where he'd claimed my work. He saw the letters from clients stating they'd work with me directly. "This is ridiculous," Daniel said, but his voice had lost its usual confidence. "These are company models. Everything we've developed has been collaborative, part of building this business together. You can't just claim ownership of work that belongs to Wright Patel Analytics." I told him that copyright law didn't work that way. I'd consulted with attorneys specializing in software intellectual property. I automatically owned copyright on code I'd written. Daniel had no legal rights to models I'd created, regardless of our business partnership. I explained that his systematic misrepresentation of technical authorship constituted fraud. He'd built his professional reputation on work he hadn't created. The evidence I'd gathered would expose his fraud completely if he tried to fight the dissolution. Daniel tried several approaches as reality set in. He suggested we could restructure to give me more recognition. He proposed changing attribution. He offered to revise agreements. Each suggestion was desperate. I told him it was too late. I'd spent 20 months documenting his theft and building exit strategy. I'd secured commitments from multiple companies to work with me independently. I had legal protection for all my technical work. I was launching my own consultancy regardless. The meeting ended with Daniel understanding he had no options. He couldn't use my code because I owned the copyrights. He couldn't maintain Wright Patel's reputation because all technical work was mine. His firm would collapse. I walked out feeling both relief and vindication. The invisible data scientist was stepping into visibility. The stolen algorithms would be properly attributed. The exploiter would face consequences. And I was launching my own consultancy with the models, client relationships, and legal protection I'd spent 20 months building. The emotional release after the confrontation was profound. For 20 months I'd worked alongside Daniel while knowing he was stealing credit for my work, maintaining professional composure while documenting his fraud. Now that facade was unnecessary. I could acknowledge the anger, frustration, and hurt his exploitation had caused without needing to suppress those feelings for strategic purposes. Within 2 weeks, I established Patel Analytics with office space in Mountain View. I chose a smaller space than Wright Patel, but one that felt authentically mine. The office had good natural light, room for my technical workstation and meeting area, and a whiteboard wall where I could sketch algorithms and model architectures without worrying about someone else claiming them as their innovations. I set up my technical infrastructure methodically. High-performance workstation with GPUs for model training. Access to cloud computing resources for larger-scale experiments. Version control systems with clear documentation practices. Monitoring and deployment tools for production models. Everything organized to support both technical work and clear intellectual property protection. The clients I'd been cultivating relationships with during my documentation period transferred their business from Wright Patel Analytics to Patel Analytics almost immediately. The transitions were seamless because these clients had always been working primarily with me on technical development. They were simply formalizing relationships that had always been based on my capabilities rather than Daniel's fraudulent claims. The telecommunications company signed a contract for ongoing model maintenance and enhancement within days of my departure. The financial services CTO committed to 3 new fraud detection projects. A retail company I'd done preliminary consulting for signed a major demand forecasting engagement. Within the first month, I'd secured contracts totaling more in annual revenue than my share of Wright Patel had generated. The validation was overwhelming and deeply satisfying. These companies were paying premium rates for my technical expertise, fully aware they were contracting directly with the data scientist who'd created the work rather than with a business partner who'd fraudulently claimed credit. The market was demonstrating that my work had genuine value independent of Daniel's business development theatrics. I also contacted technical conferences where Daniel had presented papers with fraudulent authorship. I provided comprehensive documentation including Git histories, code repositories, and development logs proving I'd created the technical work. I requested corrections to published proceedings and author listings. Several conferences investigated and issued corrections. The Conference on Knowledge Discovery and Data Mining updated their proceedings to list me as first author and sole technical contributor on a paper about interpretable churn prediction. The International Conference on Machine Learning made similar corrections to a paper on ensemble methods for imbalanced datasets. Each correction publicly documented Daniel's fraud. The data science community response was powerful and more widespread than I'd anticipated. Multiple practitioners reached out saying they'd experienced similar credit theft in consulting, corporate, or academic settings. Many described situations where business partners, managers, or senior researchers had systematically claimed credit for technical work while keeping actual developers invisible in subordinate roles. Professional organizations invited me to present about protecting intellectual property and preventing exploitation in data science practice. I gave talks at Pi data conferences, local data science meetups, and academic departments. The presentations drew large audiences, indicating widespread concern about credit theft in technical fields. The community's response demonstrated that this wasn't just my isolated experience but a systemic problem. After one presentation in San Francisco, a young data scientist approached me describing how her manager had been systematically presenting her models as his own work to executive leadership. She felt trapped because she didn't understand her rights and feared retaliation if she objected. My talk gave her both technical knowledge about copyright protection and emotional encouragement to document her work and advocate for proper attribution. She implemented the documentation strategies I'd shared, building comprehensive evidence of her contributions. 6 months later, she successfully negotiated a promotion and proper credit for her work after presenting her manager with evidence of systematic attribution theft. She credited my guidance with giving her the confidence and legal knowledge to stand up for herself. Daniel Wright's reputation collapsed completely and publicly in the data science community. Once companies and practitioners learned he'd been fraudulently claiming credit for my technical work, his credibility was destroyed in ways that ended his ability to work in machine learning consulting. Wright Patel Analytics lost every major client within 6 weeks of my departure. The telecommunications company terminated their contract citing misrepresentation and fraud. The financial services clients pulled all ongoing projects. Companies that had been considering working with Wright Patel canceled discovery meetings after learning about Daniel's systematic credit theft. The consulting referral network that Daniel had carefully cultivated over years evaporated almost overnight. Several former clients initiated legal action or arbitration seeking to recover payments, arguing their contracts were fraudulent because Daniel had misrepresented his technical capabilities and role. At least 2 companies pursued claims that resulted in substantial settlements. The legal complications multiplied as Daniel faced both client lawsuits and potential professional liability issues. Machine learning conferences that had accepted papers with Daniel's fraudulent authorship were contacted by multiple parties. Some conferences implemented new verification procedures for author contributions following the incident. Daniel's name became associated with academic fraud, effectively blacklisting him from future conference participation or publication. Daniel attempted to salvage his consulting practice by hiring other data scientists to replace my technical output, but his reputation was so thoroughly damaged that skilled practitioners refused to work with him. Word spread quickly through professional networks that he'd built his entire reputation on stolen work. No competent data scientist wanted to associate with someone who'd so fundamentally betrayed professional ethics. I heard through contacts that Daniel made multiple attempts to hire senior data scientists, offering equity partnerships and generous compensation. Every practitioner he approached declined once they learned about his fraud. Some forwarded his outreach to me expressing disgust and support for my independent practice. The community's rejection was decisive and permanent. Within 3 months of my departure, Wright Patel Analytics closed completely. Daniel dissolved the LLC, unable to maintain any business without technical capabilities, client relationships, or professional credibility. The office was vacated, websites went dark, and all business operations ceased. Daniel Wright effectively disappeared from the data science community. I learned later that Daniel had left the analytics industry entirely, attempting to pivot to general business consulting in a different city under slightly modified branding. His attempt to build reputation and success by stealing my technical work had backfired so completely that he couldn't recover even by changing locations and focus areas. The fraud had been too systematic and too public. Meanwhile, Patel Analytics flourished beyond even my careful projections. My first year of independent practice exceeded expectations across every metric. I completed machine learning projects for 8 major companies spanning telecommunications, financial services, retail, and healthcare. I published 2 technical papers, properly attributed, in top-tier conferences. I spoke at major data science conferences about both my technical work and my experience with credit theft. The telecommunications churn prediction system I'd developed became a case study featured in Harvard Business Review as an example of effective applied machine learning creating measurable business value. The article properly credited me as the data scientist who'd created the models, establishing my reputation for telecommunications analytics. The publicity generated multiple inquiries from other telecom companies interested in similar solutions. A fraud detection system I'd built for a major bank won an industry award for innovative application of machine learning to financial services. The award ceremony was emotionally significant because I accepted the recognition myself. My name was announced clearly as the technical creator, and my work was properly celebrated. The contrast with 20 months of watching Daniel accept credit for my work made the moment particularly meaningful. I was invited to keynote at the Strata Data Conference, one of the premier industry events for data science practitioners. My presentation combined technical content about ensemble methods with personal narrative about protecting intellectual property and recovering from exploitation. The talk was standing room only and received overwhelmingly positive response. Multiple attendees told me it was the most impactful talk of the conference. Within 3 years of leaving Wright Patel, Patel Analytics had completed projects for over 20 major companies across diverse industries and technical domains. I'd published 8 technical papers in top conferences, all properly attributed. My work was featured regularly in industry publications, trade journals, and academic venues. Every feature included proper attribution, establishing my professional identity independent of Daniel's fraud. The financial success matched and exceeded the professional recognition. Independent consulting was substantially more profitable than partnership with Daniel had been because I wasn't splitting revenue with someone who contributed nothing to technical capabilities while fraudulently claiming credit. My overhead was lower operating independently, my margins were better, and every dollar earned directly reflected my actual work. I also began systematic advocacy work helping other data scientists and technical professionals protect their work and avoid exploitation. I developed comprehensive resources about intellectual property protection for data science practitioners, wrote detailed articles about preventing credit theft in consulting and corporate environments, and created template agreements and documentation practices. I made all resources freely available through my website and professional networks. I worked with Dr. Chen and Stanford's Computer Science Department to develop curriculum about intellectual property protection specifically for data science students. We created a course covering copyright law for software and models, protecting trade secrets, documenting technical contributions, navigating collaborative work while maintaining attribution, and responding to credit theft. The course became required for all data science master's students and was adopted by other universities. The Association for Computing Machinery invited me to join a task force developing professional guidelines for proper attribution in machine learning research and practice. We created standards addressing how to credit technical contributions in collaborative projects, how companies should attribute data science work to individuals, and how the community should respond to documented credit theft. The guidelines were published and adopted by major conferences and companies. 5 years after leaving Wright Patel, I'm 37 and running one of the most respected independent data science consultancies in Silicon Valley. Patel Analytics has completed projects for over 40 companies, published 15 technical papers, won 6 industry awards, and established reputation for sophisticated machine learning solutions properly attributed to the actual technical creator. The professional success vindicated every difficult moment of the 20 months I spent documenting Daniel's theft while continuing to work alongside him. Every award with my name, every publication crediting my work, every client hiring me for my technical capabilities represented visibility Daniel had tried to deny me through his systematic fraud. The recognition felt earned rather than stolen. My advocacy work extended beyond personal success to helping dozens of other technical professionals facing credit theft and exploitation. I provided free consultations to data scientists discovering their work was being misappropriated, helping them understand their intellectual property rights, document their contributions comprehensively, and plan responses to exploitation, whether that meant internal advocacy or leaving to establish independent practices. One data scientist I mentored, Dr. Jessica Martinez, had been working at a consulting firm where the managing partner was systematically presenting her models as his own work to clients and at conferences. Using documentation strategies I'd shared about version control, technical journals, and copyright registration, Jessica gathered comprehensive evidence of the misappropriation. She left the firm and launched her own consultancy that's now successfully competing with her former employer. Another practitioner, Kevin Park, contacted me after discovering his business partner had been submitting conference papers with fraudulent authorship. I helped Kevin understand his options, connect with intellectual property attorneys, and document the fraud systematically. Kevin dissolved the partnership, corrected the published record, and now runs a successful independent practice while also advocating for stronger attribution standards in technical publishing. These success stories multiplied as more practitioners learned about protecting their work and refusing to accept invisible exploitation. Each person who successfully left an exploitative situation and thrived independently strengthened the message that technical credit theft deserved serious consequences and that skilled practitioners could succeed with proper attribution and legal protection. 10 years after leaving Wright Patel, I published a comprehensive book combining machine learning technical content with practical guidance about protecting intellectual property in data science practice. Data Science writes, "Protecting your technical work in collaborative environments became required reading in data science programs, widely adopted for professional practice courses and corporate training." The book covered copyright law for code and models, patent considerations for novel algorithms, documenting technical contributions, negotiating proper attribution in employment and partnerships, detecting and responding to credit theft, and case studies including detailed analysis of Daniel's fraud. The technical content was interwoven with practical guidance, making intellectual property protection accessible to practitioners focused primarily on technical work. Daniel's systematic fraud became an extensively documented teaching case in the book, his exploitation immortalized as a cautionary tale educating future generations about protecting technical work and recognizing fraudulent partnership dynamics. He had wanted to be remembered as an innovative data science consultant. Instead, he became an example of what not to do, the business partner whose intellectual property theft destroyed his career while elevating his victim to greater success and industry-wide recognition. 15 years after Wright Patel dissolution, I received the ACMSIGKDD Innovation Award, one of the highest honors in data science, recognizing both technical contributions to machine learning and advocacy for proper attribution in data science practice. The award ceremony included a retrospective of my career emphasizing how I'd transformed personal experience of credit theft into broader movement for practitioners' rights. The recognition validated that my response to Daniel's exploitation had created positive outcomes far beyond personal vindication and professional success. His theft had catalyzed advocacy, helping hundreds of data scientists protect their work and achieve proper recognition. The invisible practitioner became a celebrated technical leader and advocate. The stolen algorithms were properly attributed and widely recognized. The exploiter left the field discredited. And the data science community became measurably more aware that credit theft deserved serious consequences. That's the ultimate outcome when exploitation meets someone talented enough to succeed independently, methodical enough to document and plan carefully, and committed enough to transform personal justice into advocacy benefiting others. Stolen credit was restored. Fraud was exposed publicly. The exploiter was destroyed professionally. And data science became measurably better because one person refused to accept invisible exploitation and fought not just for herself but for every practitioner facing similar theft.